Welcome to this explainer. Today, we're tackling a challenge that practically every back-end automation developer runs into at some point, building a reliable, production-ready CAPTCHA workflow in an Elixir Phoenix application. If you're building automated flows that touch a protected form, login, or workflow, you're in exactly the right place. We're going to take that brittle script you've been using and transform it into a truly robust engineering system.
So let's just dive right in. I want you to ask yourself a really honest question. Do you think your CAPTCHA integration is production ready just because it works on your machine? A lot of developers assume that if their integration successfully returns a token locally, the job is totally done. But honestly, that's one of the biggest mistakes teams make.
There's this massive divide we see all the time. On one side, you've got the classic works on my machine scenario. It's the happy path demo, everything executes perfectly on your local dev environment. But then there's the harsh reality of production. When you deploy this thing to run unattended in CI pipelines, inside scheduled OBON workers, or behind an internal queue, the environment totally changes. You're dealing with deploy windows, network hiccups, and unexpected API timeouts. What looked deceptively simple locally suddenly just falls apart when it's left completely unattended.
To help you cross that divide, here's our roadmap for today's explainer. First, we'll do a production reality check, then we'll walk through the core workflow checklist. After that, we'll look at resilience and system metrics, highlight some really common integration mistakes, and finally wrap up with some quick FAQs and safety tips.
All right, let's get into Section 1, the production reality check. This requires a fundamental shift in how we think about automation workflows. I absolutely love this quote from our source material because it really hits the nail on the head. What you actually need is predictable solve latency, clean failure modes, and code that another developer can read in 5 minutes. See, your core engineering goal isn't just getting a token back. Your goal is building an integration that handles network instability and CAPTCHA changes all on its own, without you having to manually handhold the system, and definitely without a barrage of PagerDuty alerts waking you up at 2 a.m.
Which brings us to Section 2, the core workflow checklist.
Let's break down the essential submit and poll loop with these first 4 steps. Step 1, validate your request inputs. Before you even think about touching the solver API, capture the exact live HTML and network calls. Sending the wrong site key, page URL, or action values creates false debugging paths that will literally waste hours of your time. Step 2, handle API errors properly. Never assume every response is a success. Treat any non-200 status as an error, log the full response, and get it into your monitoring tools. Good logging today saves you so much time tomorrow. Step 3 is about polling efficiently. Don't spam the API. The sweet spot is to submit the task, wait exactly 15 seconds before your first poll, and then poll every 5 seconds, capping it at a hard 120 seconds. And step 4, this is a real game changer. Keep everything in the same session. The token has to be applied in the exact same browser context or HTTP cookie jar that actually triggered the challenge. Moving right along to Section 3, resilience and system metrics. Because it's not enough to just run the workflow once. It has to stay healthy over thousands of iterations. That brings us to Step 5 on our checklist, establishing a retry budget. Look, it is super tempting to just slap an infinite retry loop on your integration, but you've got to resist that urge. Retries should recover from temporary issues, not hide permanent ones. Cap your retries at 3 attempts and use exponential backoff. Infinite retries just hide real underlying defects in your code and needlessly burn through your API balance. Log every terminal failure so you actually know when things break for good. Step 6 is all about measuring the right metrics. If you can't measure it, you can't defend it. For a healthy system, you want your first solve latency under 25 seconds for token CAPTCHAs. You also need to watch your solver success rate, which proves your inputs are correct. But honestly, the most crucial metric, end-to-end acceptance. It needs to be 95% or higher. A solved task from the API is completely useless if your own downstream application rejects it. End-to-end acceptance proves you're actually managing that session handoff perfectly. And wrapping up our checklist, Step 7, build for future changes. The reality of the web is the CAPTCHA implementations evolve constantly. You want to design your Elixir code to be modular from day one. Since APIs like CAPTCHA AI expose a single interface across different CAPTCHA families, if a target site changes their security, you shouldn't have to rewrite your entire application. You should just be able to swap the task type in your configuration, keep your existing submit and poll loop, and ship it. Okay, on to Section 4, common integration mistakes. Let's run through the anti-patterns developers trip over again and again. First up, Using wrong request parameters. Like we said, garbage in means you fail before you even start. Second, session mismatch. Applying a solved token from a totally different session guarantees an instant rejection. Third is overpolling, which just hammers the API and adds noise without speeding anything up. Fourth, unlimited retries. We know this one just masks permanent bugs and drains your wallet. And fifth, ignoring downstream monitoring. If you only track API success, you literally have no idea if your overall workflow actually finished the job. Avoiding these specific pitfalls is going to drastically improve your production reliability.
Finally, let's head into Section 5, quick FAQs and safety.
We're going to tackle the rapid-fire questions developers ask when they're in the trenches debugging this stuff. Starting with the big one. My logs show a successful solve from the API, so why does my solved token still get rejected by the target form?
Almost every single time, it's because the token was submitted from a different browser or HTTP session than the one that originally generated the challenge. You absolutely must keep the solve and the form submission tightly coupled inside the exact same HTTP client context and cookie jar. Changing sessions midway through is a guaranteed fail.
Next question. When I'm setting up my observability dashboards, which metric is the absolute most important to monitor first? You have to start with end-to-end workflow completion. It's so easy to get a false sense of security if your solver's success rate is 99%, but your actual workers are failing to submit the final form. End-to-end completion is your ultimate source of truth. It tells you if the whole business process succeeded, not just the API call. And our last FAQ, how many retries should I configure to properly manage my infrastructure load and API costs? The concrete answer here is a limited retry policy. Cap it at a maximum of 3 retries combined with exponential backoff. Do not use infinite loops. If a CAPTCHA fails 3 times with backoff, something structural is probably broken. Either the page layout changed or your parameters are bad. Fail the job gracefully, log it, and go investigate. Before we wrap up, we have to talk about a critical safety and ethics reminder directly from our source material. Use only in owned, client-authorized, or contractually permitted environments. This technology is incredibly powerful, but it comes with professional responsibility. You should only be automating these flows on your own applications for clients who've explicitly authorized it, or where you have a clear data collection agreement in place. I want to leave you with this final provocative thought. The goal isn't simply to solve CAPTCHAs. The real goal is to build automation that's reliable, observable, and easy to maintain in production. When you implement a proper submit and pull loop, respect session boundaries, and monitor the right KPIs, you transform a brittle script into real engineering. So before you merge your next pull request, ask yourself, are you just writing a script to get a token, or are you architecting a resilient system? If you found this explainer helpful and want to see the actual Elixir code snippets to make this happen, I highly encourage you to check out the full technical guide from CAPTCHA AI. Thanks for hanging out and keep building robust systems.